Hello there and welcome to A2 Maths from Specimen Paper 1, and here we're looking at question 11, a differentiation question. So figure 5 shows a sketch of the curve C with the equation y equals f of x. The curve C crosses through x at the origin, O, and at the points A and B as shown in figure 5. Given that the derivative of f of x is equal to k minus 4x minus 3x squared, and k is a constant, part A is show that the curve C has a point of inflection at x equals minus 2/3. Now, first of all, what is a point of inflection? Well, it's the point at which the gradient is increasing to the point where the gradient starts to have a lower value. I'd expect it to be around this point here. In between this part here and this point here, the gradient is positive, but it's also increasing. The value of the gradient is increasing, but from this point here to this point here, the gradient is still positive, but it is decreasing in value. The gradient is now getting smaller and smaller and smaller. The value of the gradient is decreasing. So it's the point at which the gradient stops increasing and starts decreasing, or the other way around, stops decreasing and starts increasing. Or in other words, it's the rate at which the gradient is either increasing or decreasing is equal to 0. Now, how do we work out the point at which the gradient is neither increasing nor decreasing? Well, it's the point at which the second derivative is equal to 0. That's what we use second derivatives for. It's to measure the rate at which the gradient is either increasing in value or whether the gradient is decreasing in value. So the second derivative of this function is going to be minus 4 minus 6x equals 0. So therefore x is equal to minus 2/3. So there we are, that's how we work it out. X equals minus 2/3, you differentiate it again to get the second derivative, set it equal to 0, that's your point of inflection. Part B now, quite a difficult question. This is 7 marks, so I know it's going to be difficult. Given also that the distance from A to B is equal to 4 root 2, showing you're working the integer value of k. So we know k is a whole number, that's a little bit of a help. But first of all, we only at the moment have the derivative, and the derivative doesn't actually tell us much about the solutions or the roots of a curved polynomial. So what we'll do is we'll get it back to the original function by integrating it. So from this line to this line is by integration. So it's going to be kx minus 2x squared minus x cubed, and then plus c on the end, because you always need a plus c for integration. Now, we know it goes through the point 0, 0, so when we plug in 0 in as our x value, we should get a value out of 0. Now, what this means if I put 0 in here, here, and here, is that I'll just end up with my value for c, so it must be the case that c is equal to 0. So now I've got a simplified curve, which is kx minus 2x squared minus x cubed. Now what I need to do to find the points A and B, these are the points at which the curve is equal to 0. The y coordinates here and here are both equal to 0, so the output of these x values is going to be 0. So let's set them equal to 0. Let's divide through by x, because at these points x is definitely not equal to 0. And let's just now move everything onto the other side. Now this is our quadratic that we can use to help solve to work out these two values here. Now the best thing we can do really to find these two solutions here is either we could use a quadratic formula, or we could also complete the square. So x plus 1 squared minus k minus 1 equals 0. So therefore x plus 1 squared equals k plus 1. So therefore x plus 1 is equal to the plus minus of the square root of k plus 1, and then when we take away 1 onto the other side, it's going to be minus 1 plus or minus the square root of k plus 1. Okay, so how does this help us? Well, we know that one of these roots, this one here, this root here is probably going to be -1 minus the square root of k plus 1. And then this point here is going to be the more positive solution, which is 1 plus the square root of k plus 1. Now, if we know the difference between this and this is equal to 4 root 2, then when we subtract one from the other, we are going to get 4 root 2. So let's in fact that needs a minus in front of it. Let's actually add the distance from here to here and the distance from here to here together. So the distance from there to there is going to be 1 plus square root of k plus 1. But the difference from here to here is going to be -1 plus square root of k plus 1. So the total distance from A to B is going to be the square root of 2 lots, so the square root of k plus 1. Because the -1s will cancel each other out, and then we've got 2 lots of the square root of k plus 1. And this is equal to 4 root 2. So cancel out a 2 from both sides. And let's now incorporate the 2 inside of this square root. So it's going to be square root of 8, which needs to equal the square root of k plus 1. So it must therefore be the case that k is equal to 7. So there we are, that's how we do this sorts of question here then. So the first thing we did for part B was we integrated to work out the equation of the curve. Then we worked out the roots at A and B. We had k in the equation, so it's pretty difficult to work it out, but we just used k in our answer. And then we worked out the distance from A to B by working out the distance from A to the origin and B to the origin. And then all we did from there was we set the distance from A to B equal to what we're told it was equal to, 4 root 2, and then we got k is equal to 7. So pretty tricky question there, 7 marks for that in total. Hopefully that made sense and you followed it. If it didn't make sense, then try it again tomorrow once the idea has had a chance to assimilate itself and you've had a chance to consolidate it in your brain on your own. Otherwise, if it didn't make sense, then go and ask a teacher. That would be the best advice that I can give you, because then you can ask questions as to how you do it. Otherwise, you could watch the video again to see if it makes sense a second time or a third time round. That's another option to you as well. But there we are, 10 marks for that question 11 there. Let's now move on to question 12.